Right, Algebra 2, Lesson 4.3, Dividing Polynomials, right? So example 1 here says we're going to divide this polynomial right here by x squared plus 3x plus 2. First of all, you have to understand that this problem here, they could write it like this, or they could write it with the division bar, okay? So what you're dividing by goes in the denominator, okay? Or they might write the problem with just the division symbol like this, right? So all three of these mean the same thing, okay? So depending, on a test or quiz, you might be given the problem in different ways. So you have to understand that all three of these, all right, they're asking you to do the same thing, okay? So dividing, all right, polynomials using long division. So if you remember long division from elementary school, we're pretty much going to do the same thing but with polynomials, okay? So I'm going to show you how to set everything up. So first of all, let's make the long division bracket. Right, so we have our long division bracket. Now whatever is in the numerator, okay, we're going to put it inside the bracket. Alright, but there's something really important. You have to always make sure that if there's any missing terms, you put a 0 in place of it. So you notice here, the numerator, we have an x to the 4th. That means the next term should be an x to the 3rd, which it does have. And the next one should be x squared. But you notice there's no x squared here. So we have to make sure we put a 0 there in replace of it. So when you're setting it up, we have 2x to the 4th plus 3x to the 3rd. And then since we're missing the x squared, you have to put the plus 0x squared. Alright, so you have to have this, or else you're most likely going to make a mistake. Okay? So make sure when you're setting up the problem, anything in the numerator, right, whatever's in the numerator, if it's missing a term, you have to make sure you put the 0 there, all right, in place of it. Now what you're dividing by goes on the outside. X squared plus 3x plus 2, right? What you're dividing by, if that's missing a term, you don't need to put a 0 for it. That's not necessary, right? So you only need to make sure you put the zeros for what's on top of the fraction or the numerator, okay? So the way long division works is this. All right, let me erase this real quick. Basically, the idea is this. We need to find something, right, times x squared that will give us 2x to the 4th, okay? Well, we know that that's going to be 2x squared, right? 2x squared times x squared will give me 2x to the 4th, right? So once you find this value, you're going to multiply it to everything, right, on the outside here, right? Basically what you're dividing by. So I'm taking this 2x squared, I'm distributing it to everything on the outside here. So that's going to give me 2x to the 4th plus 6x to the 3rd plus 4x squared. Okay, and then we're going to subtract. Now if you remember, whenever we're subtracting, we're going to add the opposite. So you're going to change this minus to a plus, right? And everything on the bottom here has to become the opposite of what it was. So this will become a negative, this will become a negative, and this will also become a negative. Okay? Now if you're doing this correctly, the first terms here in the front should always cancel out. Okay? If they don't cancel out, that means you're probably doing something wrong. And then we're combining like terms, so we end up with negative 3x to the 3rd. This gives me negative 4x squared. And then what you want to do is bring down the next value, the positive 5x. Now we're going to repeat the process. So something, right, something times x squared has to give us negative 3x to the 3rd. Well, that's going to be negative 3x, right? So once you find this value, you're going to multiply it, distribute it to everything outside, right here. So that'll give us negative 3x to the 3rd minus 9x squared, then minus 6x. then we're going to subtract, right? So when you subtract, that means you're going to add the opposite. So change this to a plus, and all these need to become the opposite. The plus, 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 right? So like I told you, if you're doing this correctly, the first terms should cancel each other out. And then we end up with right here, 5x squared plus 11x. Bring down the next value, which is minus 1. Repeat the process. Something times x squared has to give us 5x squared. Well, that's going to be plus 5. Now I'm going to take the positive 5, distribute it to everything outside here. So that'll give me 5x squared plus 15x plus 10. Subtract. So we're subtracting, that means we add the opposite. So change to a plus. Everything has to become the opposite. First term should cancel. This will give us negative 4x, right, minus 11. And there's no more value to bring down, so you're done. So what that means is this is your remainder, right? So this is the remainder here. And whatever the remainder is, this is how you write it. You could just put a plus, and then whatever the remainder is, negative 4x minus 11 divided by whatever you divided the problem by, what's on the outside here, x squared plus 3x plus 2. And the top part here, this is your answer. Okay? So that's pretty much how long division works with polynomials. So let's take a look at this second example here. So let's set everything up. So first of all, notice we've got a missing term, right? There's no x to the third, so I need to make sure I put in that 0 when I set things up. So let's set everything up. So I've got x to the fourth plus 0 x to the third. So I have to make sure I put in this missing term. Then plus 2x squared minus x plus 5. And I'm dividing by this, so this goes on the outside. Okay? So I've got x squared minus x plus 1. So now let's start the process. So something times x squared has to give me x to the fourth. And that's going to be x squared, right? So if I multiply here, that gives me x to the fourth. If I multiply here now, that gives me negative x to the third. If I multiply here, that gives me positive x squared. Then I'm going to subtract, right? So when you subtract, that means to add the opposite. I change this to a plus, everything becomes the opposite. The first term should always cancel if you're doing things correctly. Right? It looks like this right here is going to give you x to the third, and this will give you plus x squared, and then bring down the next value, minus x. Repeat the process. Something times x to the third, something times x squared will give us x to the third. So it looks like that's going to be positive x. Okay? So I multiply, and I end up with x to the third, multiply here, that becomes negative x squared, multiply here, that becomes positive x. I subtract, so that means I'm going to add the opposite, right? So the first term should always cancel. Looks like that's going to give me 2x squared minus 2x. Bring down the next value, plus 5. Repeat the process. Something times x squared will give us 2x squared. So that'll be positive 2. So I get positive 2x squared minus 2x, and then plus 2. Right? Subtract. So that means to add the opposite. That'll become a plus. Everything becomes the opposite down here. First terms cancel. Second terms also cancel. And And then we're left with, I believe, positive 3 as our remainder. So the way we write it, we'll just put a plus 3 divided by, what we divided by, x squared minus x plus 1. Okay? So you notice long division, right, is quite a lengthy process. So another way to divide polynomials, right, is a method called synthetic division. Okay? But you can only use synthetic division if you're dividing by something in the form x minus c. Okay? So what that means is, let me give you an example. So it's okay to use synthetic division, right? So synthetic division, it would be okay to use synthetic division if you're dividing by. Okay, so this is what you're dividing by. Okay, something like x minus 2, right? Or x plus 5. You can use synthetic division, right? Synthetic division, not okay. So you cannot use synthetic division if it's like x squared plus 2, or x squared minus 5, or x to the third plus 1. You cannot use synthetic division. So whatever you're dividing by has to be in the form x minus some number or x plus some number. Okay? So if you're dividing by something that looks like this, you can use synthetic division. Okay? And synthetic division makes the process much, much faster. Okay? But there are only specific types of problems when we can use synthetic division. So synthetic division here, so example 2, right? So first of all, we're dividing, okay? So we have negative x to the third, right? Plus 4x squared, and I notice I'm missing a term, so I have to put in that 0. So even when you're doing synthetic division, you have to make sure you put in the zeros, okay, whenever you're missing a term. Then you have plus 9, right? Now since we're dividing by x minus 3, I can use synthetic division, okay? Now in this case, right, my c is going to equal, right, positive 3. So you have to remember, if it's x minus 3, c is going to be the opposite, right? So if it's minus 3, you do the opposite. It's plus 3, okay? So the way this works is synthetic division. What you care about is you care about all the coefficients. So we care about this negative 1, this 4, this 0, and the 9. Then you're going to put like a little box here, and the c goes in the box. So in this case, c is positive 3. Okay? And then what we're going to do is we're going to always drop down the first number, negative 1. Now, you're going to multiply the c, right, with the numbers on the bottom here. So negative 1 times 3 will be negative 3. And that will go in the next missing spot right here. And then we're going to add these numbers. That gives me positive 1. And then we multiply, all right? So the amount of numbers down here, we multiply with the c. So 3 times 1 is 3. That goes in the next missing spot here. We add these numbers, we get 3. Okay. Multiply 3 times 3, we get 9. That goes in the next missing spot. Then we add these numbers, we get 18. This final number here is your remainder. Okay. Now this is how you write your answer. Now every time you do synthetic division, the exponent goes down 1. So if our problem started with x to the third, that means now this is going to be x squared. So our answer is negative 1x squared plus 1x plus 3, and then this is our remainder, plus 18 divided by our divisor, which is x minus 3. Okay, so this is our answer here. So you notice the process, once you understand it, is really, really quick and a lot faster than long division. Now, if you actually divide this using long division, you get the exact same answer. It's just a much longer process. Okay. Let's take a look at example 3 here. So let's check to see if I'm missing any terms. I've got x to the third, x squared, x, then the 5. So we're not missing any terms, so we're good to go. Right? And then I'm dividing by x plus 1. So that means my C is -1. Okay? So then let's take the coefficients, 3, right? So we've got the coefficients 3, -2, +2, -5, and our C is -1. Drop down the first number, multiply, right? -3, add, -5. Multiply, +5, add, 7. Multiply, -7, add, -12. That's your remainder. The problem started with x to the third, so that means this is going to be x squared. So our answer is 3x squared minus 5x plus 7 plus -12 divided by x plus 1. Okay? Alright, the next example here. So they're telling us to evaluate this polynomial right here. Okay? And they're telling us x equals -4. Okay? So this means the same thing as they're telling you c equals -4. So they're already telling you what c is. Okay? Because we're going to evaluate this using synthetic division. Okay? Now, are we missing any terms here? So x to the third, x squared, x. So we're not missing any terms. So all we care about are the coefficients. And then our c. So when they tell you x equals some number, that means they're telling you this is c already right here. Okay, so c equals -4. So we're going to put in -4 here. So make sure you don't do the opposite when they tell you like x equals something, right? So that number is already the c. Okay, so you don't do the opposite in this case. Okay. So we drop down the first number, right? So we're going to end up with, we multiply, that's -20. We add, so that's -21. We multiply, so that'll be 84. We add, that's 97. Then we multiply that for -4 and 97. We end up with -388. We add, so that's -359. So that's our remainder. Now when they tell you to evaluate the polynomial, that means all you care about is the remainder, right? So your answer here, you just say is -359. This is all you care about, okay?